Hello everyone, hope you all are doing well. If you are new to this channel or this playlist, then we started from the Leetcode crash course and then we moved on to some exhaustive list of linked list related problems that we are going to solve together. And this is a video in continuation of that. And today we'll be solving a couple of problems. First one is merge two sorted list, and the second one is merge k sorted list, right? Let's move to the first part. Since these two problems are similar, that is why. And again, we'll be developing the intuition as to how to solve this problem, right? So the problem is very easy. It says that given you are given the heads of two sorted list, L1 and L2, merge the two list in one sorted list, and the list should be made by splicing together the nodes of the first two lists, right? Return the head of the merged linked list, right? That is what it says. Let me just give you an example. Like for example, I have this list 1 2 and 4, and then I have another list, and that is 1 3 and 4. What I'll be needing is you pick this one. Sorry, just a second. Yep, now I pick this. Yeah, you pick this one, it comes here. So 1 now. So and now first you compare these two. Which one is the smaller one? Suppose you pick this one. In case of equal, suppose you pick this one. So you put this in your answer. Now you check this and this, because this is exhausted. You check this and this. Which one is smaller? This is smaller. Put this node here, right? Now you check this and this. Which one is smaller? This one. So you put it here. Now this is gone. Now you check this and this. Which one is smaller? This. So you put this here. You check this and this. Both are equal. Put any one. This is 4. This is gone. Nothing to check here. This is the last node. Just put it here, right? Right. So what you are doing, use these nodes only and basically merge these two lists. That is what it says. So you are given to merge you are given two sorted lists. You need to merge them, right? So that is the problem. And nothing too much fancy here, to be very honest, as I told you. So suppose you have two arrays, right? Let me just take the example of two arrays. So suppose the indices are 1 2, just like this, right? And you have another array 0 1 2 3 4 5 6 like this, right? So forget about optimization. Suppose someone says that form a new array which has the elements of these two arrays but in the sorted order. This is also sorted, this is also sorted. So what is the basic stuff that you will do, right? Forget about coding. The basic stuff will be, you will compare the first two elements, right? You will compare the first two elements. Suppose this one is smaller, this one is smaller. So what you will do, you will keep this element here, you will put this element here, right? Now you need to fill this index. This index is filled, you need to fill this index. Now to fill this index, what are the numbers that you will compare? Now this one was already exhausted, so you will check this number and this number. Now whichever one will be smaller. Suppose this is smaller, what you will do, you will put this number here. Now I need to fill this one, so you will check this position and this position. Suppose this one is smaller, you will put this number here. Now what you will do, you need to fill this position, so you will check this position and this position, and so on, right? So basically what you are doing, you are just keeping a couple of pointers on the two list and then traversing. Whichever is smaller, just put that into your answer and move one step ahead in that particular list, right? Now an advanced version of this problem is, if I just show you, then advanced one is the second one that we wanted to discuss. This is the hard level problem. Let me just fetch the code as well. So you are given an array of k linked list. Each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. Now this one is a much better problem as compared to the first one. So in the first case you had two linked list. Now in this case you have k linked list. Just a second. Yeah, you have k linked list. So you can have 1, you can have 2, and so on. So theoretically speaking, what you can do, suppose you have 4 linked lists. In this case k equals to 4. So what you will do, you will, in layman terms, you will take 4 pointers, 1 2 3 and 4, all of them pointing to the starting node of the 4 list, right? And suppose this is your answer list. What you will do, you will compare these 4, 1 2 3 and 4. They are initially they are starting pointing to the start node of all the 4 lists. you'll pick up the smallest one. Suppose this is the smallest one, so you'll add this to your answer. Suppose you are making a new list, so you will add you, and this is answer. So you add this answer points to this node, right? Now next, now since you have processed this, you'll move one step ahead. Now it will point here to the second node in this list. So second node in this list, first, and these three lists, right? Basic stuff what you did for the in case of two list. Now suppose this is the smallest one. What you will do? You will put this value here because I want a sorted merge list, and then this pointer will move one step ahead. It will move here. So this is pointing to the second node, this is pointing to the first node, this is pointing to the second node, this is pointing to the first node. Simple stuff, right? Now practically speaking, if I have 10,000 10k list, 10k sorted list, and I want to merge them, then obviously keeping 10,000 pointers is not at all possible, right? Is not at all possible. Let's think in other way. The other way around is, what I am doing is, among the k list I want the smallest value, right? Like all the 4 lists are pointing to some values. Now whichever is the smallest one, I want to pick it up. I want to pick it and then move that particular pointer one step ahead, right? So my main problem reduces to how do, among k list, how do I find basically a node having the smallest value among the k list that I have been given, and then once I pick that value, I move the pointer one step ahead, right? So if you guys are familiar with priority queue, so or heap data structure, then what happens, what priority queue does is, you put some values. It is a tree like data structure, right? Something like this, right? Something like this. Forget about the internal implementation, just consider that it is a black box for you. It is a black box for you, and what it gives you, you put some values here, right? You put some values here, and you can tell the priority queue that sort my values such that I want either I want the maximum value at the top or I want the minimum value at the top. It totally depends on you. So suppose I take a min priority queue. Forget about the internal implementation. Just consider it's a magical box, right? So you take a data structure, you put, so for k list, what you do, you put all the k values here. And what are those k values? So initially you put the list, you basically put the a pointer to those nodes, right? Initially for all the list, the pointer is pointing to the start node. So what do, you put all these things, you put all these nodes into the priority queue, right? You put this into a priority queue. Now what will happen, and you say the priority queue that whichever node has the minimum value, so for all the k list, I am picking up the smallest value for those k list, right? Whichever is being pointed, I pick those k values and put it into priority queue. Now whichever is the smallest value, it is at the top. Now what I do, I want to construct my answer. I pick the smallest one. I basically start constructing my answer. I keep the smallest value here. Now once I kept the smallest value here, I want to know that from which list did I fetch this value. It can be any of the k list, right? So along with that, what I can do, I remember in my priority queue, I put up I had basically inserted the nodes, and a node has a property in linked list that I can do node equals to node.next, right? So what I do, I basically add this node into my answer, and then for this particular list, I again put node.next value. Just a second. Yeah, I put node.next value, that is the next value in that particular list, into the priority queue. Now again, what priority queue will do, as soon as you will insert a new value, again it will do some sorting stuff, and then again the minimum value will come at the top, right? Again what you will do, you will pick up the minimum value, you will append it to your answer. Suppose in this case it was n1, suppose it came for this list, so and it was pointing suppose here, right? Now you want your pointer to move here, you want to put this value in your priority queue, right? Because at every step you want the minimum value among the k possible list that you have, right? So what do, you do n1 equals to n1.next, put this value here, and again this magic will happen, right? Obviously you need to take care of the null cases and all, but this is the basic concept, use of a priority queue, and then we are good to go, right? Let's jump into the code. because I don't want to discuss too much about priority queue, because probably we have not discussed that right, till now. But just consider it. It does some sort of sorting internally, a tree-like data structure, basically a heap, which keeps the minimum or the maximum value, whatever you say it, right? So you can see on line number 13, int k equals to list.length. That is the number of lists that I have. Now if k equals to 0, that means I do not have any list, then just return null. On line number 17, just see what I have done. Priority queue of list node. So list node is the data type of the values that I'm gonna put into the priority queue, right? So queue equals to, again, priority queue, list of node. The length of the priority queue will be k, that is why I put k comma x comma y. Now this is a comparator. Comparator basically says whenever you sort this or heapify the values that I put into you, what is the relationship that you're gonna use to sort the values. So the relationship is, if you, while sorting, if you get two values x comma y, then x dot val minus y dot val. That means put the smaller value first. This is the basic meaning of it, right? We can go more into the syntax, but this is the stuff what line number 17 is saying. Now what do? You have told I have a priority queue and the comparator will be this. On line number 18, what I have done, I have traversed all my list. I have checked if my current list is not null, then just add the first node of those lists into the queue, right? I have done that. Queue dot add list. Now list is obviously the first node of each and every list, right? Now what I do, on line number 22, I say answer equals to new list node and temp equals to answer. As I am been telling you, I take a dummy node initially to avoid null checks and all. Now what I am doing, while queue is not empty, this is a function which tells that your priority queue is empty or not. Now while my priority queue is not empty, what I do, I fetch the current node. Now as I told you, it's a min heap, so you get the minimum value in your priority queue. So current equals to queue dot poll. So what you do, temp dot next equals to current. That means your answer list, the next pointer of your answer list, wherever it is, will point to the current node, and then temp equals to temp dot next. Now what do, you check, you want to insert the next value of this list into the priority queue, right? Because now the number of elements in the priority queue is k minus 1. You have pulled out one value, you want to insert the next value in the list which you have just used. So you do, if current dot next is not equal to null, that means if you have next node in your list, then that just insert that into your priority queue. Now on line number 24, the check will keep on happening until and unless every node is exhausted for all the lists, right? So that is why while queue is not empty, you do this stuff, and finally you return answer dot next, right? So yeah, this is the small code that we'll be needing. The basic concept to cover here was priority queue. Instead of taking multiple pointers, you just take this thing and we are good to go. So yeah, and if I tell you about the first problem, the easier one, then it is very easy. Again, you basically take two pointers in this case, and then just do some comparisons, and finally you construct the new list, right? So obviously if you have seen this solution, merging k sorted list, then that is a cakewalk, right? You can see it's an easy level problem. So yeah, I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries, do let me know. I'll be more than happy to revert on each one of them. Thank you. Take care. Bye bye.